Welcome to Walailak University Global Program. Again, this program is to disseminate information about activities that involves international visitors, our international activities in the area of teaching and learning and research, and also student activities. Today we have two visitors from two professors from British Columbia, Canada, visiting Walailak University, and we are very fortunate to welcome Professor Lam, Frank Lam, and Professor Lee to the program today. Professor Frank Lam is a senior chair professor at the Wood Building Design and Construction, the University of Columbia, British Columbia, and Professor Minghao Lee at the Department of Wood Science, working on sustainable timber built environment unit. Again, also from the University of the British Columbia. Welcome both of you to the program, to professors. So first of all, can you begin by telling us the purpose of your visit to Walailak University?
So thank you very much for the invitation to come to your university. This is my second visit. The first visit was 10 years ago. The main purpose of our visit is to collaborate with one of your associate professor on his research project on the development of engineered wood products from using oil palm wood as well as rubber wood. So we have a short visit. We're going to have a chance to visit your lab, as well as give a presentation on some of the ongoing research activity at UBC, as well as globally what's happening in the area of mass timber construction.
Timber construction, yes. Professor Lee?
Thanks for the invitation. It's such a great pleasure. And for me, this is the first time to come to visit Thailand. And I really appreciate the invitation from Professor Sutton. And I would say, as Professor Lam said, this is a great opportunity for us to come over to see what you are doing in the engineered wood product development area, and also we share the same interest in using wood for a more sustainable built environment.
Mm-hmm. Yes, the issue of using wood to build buildings, I think UBC, the University of British Columbia, has demonstrated very clearly the efficacy, the usefulness of using wood to build in place of cement, which is not very friendly to the environment. And so by using wood to build buildings, it helps store the carbon dioxide and therefore reducing the rate of carbon dioxide emission to the atmosphere. So this is a great contribution. And so I'm just curious about the extent to which you have done this research and then have already demonstrated in the practical use of wood to build such a high building in Canada. And so could you say a little bit more about that?
Yeah, maybe I'll start off and then Dr. Lee will continue on the subject. UBC has a very strong commitment in the area of sustainability. So we have Institute of Sustainability on campus, and the university has initiated projects in terms of using the campus as a learning, using building as learning environment. In that case, we are breaking the envelope, having built buildings that would otherwise not been easily realized in the commercial world. As such, there are many wood buildings that have been built on campus using new technology. So in this approach, we allowed practicing engineers, architects to try new ideas. we allowed wood products producers to quickly introduce their product into the system, and really short track the commercialization of some newly invented wood products. And at the same time, we learn about it. We learn what to do, what not to do. So of course, some mistake can be made, but then through time, we can sharpen our pencils and look at the most efficient path forward. One example, a very good example, is a building that was built, an 18-story building that was built as a hybrid building, combination of mass timber as well as reinforced concrete. So at that time when it was built, it was 2017, I believe. Yeah, it was the tallest modern timber building in the world. And it was built as a student dormitory with 400 beds for students. So you can imagine the extra safety and consideration that have to be put together in order to have something like that built. And the university, although it is the push and the will is to build this, to try new things, the very strong point is that they do not want to spend extra money compared to a normal way of building. Of course, it cannot be done easily with new construction ideas. So in doing so, we had the government came in and said that we're going to help support some of the issues in order to clarify how to build these type of buildings. So there was a competition being held actually in Canada, and they supported 3 projects, and one of which is this University of British Columbia project. At the end, I think the cost is about 10%. Less than 10% over that of reinforced concrete, but then it was doable, right, and reachable. Of course, this is the first time this type of building has been built in the world, and you have to pay a bit of extra. And also, having said that, at that time when the building was built, the building code does not allow building of such height to be built with wood, because primarily of fire concerns, and also there's some issues that need to be solved in terms of seismic resistance. And both of which has been dealt with successfully through the extra research work and technical evidence that was provided to support such building structure.
Mm-hmm. Yeah. It's quite extraordinary to use wood to build such a tall building, as you mentioned, 18-story building at the University of British Columbia, and also to house students as well. So did you say 400 students live there? So that's a huge building. Was it the first in Canada to venture in? Well, first in the world. First in the world. Yeah. So and that is part of your. It's a result of your research, really, and you have people like Professor Lee to be part of that. Would you like to add more to that, please?
So I think, this is building serves as a catalyst for many other similar buildings being built around the world. For example, currently the tallest modern timber building is actually in Milwaukee in the United States, but it essentially used the exactly same structural system. Okay, so the gravity load system mostly is carried by engineered wood products, and the lateral loading is a concrete core system. So it's a good example of using 2 types of construction materials to meet the building code requirement.
Right.
So, and also I want to echo Professor Lam's sustainability aspect of using more mass timber for building construction. As you know, the Canadian government has set this climate change target. So by 2050, so the government wants Canada to achieve the neutral carbon. It's a 0 carbon emission. So we know this is a really important target for us to really slow down the global warming, tackle the climate change. And for UBC, the university itself also set even more ambitious goal to achieve net zero emission by 2035. So one option or one solution is to use the lab as a living lab to demonstrate the sustainability activities on campus and to use more sustainable construction material. So one good example is to use sustainable timber products.
Sustainable timber products, that's the key there. Yeah, right. Mm-hmm. Now, in the case of Thailand, you've come here, you have Thai professors, the researchers who are part of your research scheme and all of that. So, can you comment on the progress, if I may? I'm not sure whether it's fair to the Thai researcher there, but are we advanced enough in terms of research on using wood to for industrial, for commercial use in such a way that they're being done in Canada?
I think you were at the beginning stage where at this moment your university is doing research of how to make this type of wood products. Of course, there are challenges with the resources you're working with, the rubber wood as well as the oil palm tree resource has its own particular characteristic that need to be studied carefully in order to create this type of products for the marketplace. So you're making very important breakthroughs, in my opinion, because you have the resource here, right? Mm-hmm. And you know best how to use the characteristic of this resource. The challenge is, of course, to convert that into a commercial wood product. Mm-hmm. So in that sense, there's a need to convince the industry, the government, etc., to I wouldn't say buy into this idea, but really adopt the idea of it can be done not only good for the environment, but also good for the business solution, right? It has to be able to have a commercial value. The dollar sign has to be there. Yeah.
So as we live in tropical country, can I ask what the difference between like using the wood found in Canada or found here in Thailand? As you said, like you use local wood to build it.
The material that you have is a different. It's not the way that we understand softwood, because in British Columbia is softwoods. So the fibers are different, and there's higher variation in density within the material. So how to create that into a more uniform wood structure is of technical challenge, and which I think your staff and your professors are trying very hard to achieve.
So you're talking about oil palm trunks and rubber trees and all of that.
Yeah, but at the end, the basic advantage, one of the basic advantage in terms of environment is that this material are still made with carbon, right? So, well, the concept is that when we take the carbon from this natural material and turn it into structural wood product, we are storing the carbon in the building, and for the life of the building, the carbon is being banked. At the same time, also processing this material into structural wood product compared to reinforced concrete, compared to the steel, it has a much lower carbon footprint and energy footprint. So there are two advantages, right? One is the carbon storage, the other one is the processing advantage of this type of material. So of course, the challenge is to document all this, make it into provide the technical information to support this, and the other end is to convince the builders and the producers that there's a commercial viability in the process.
Right. Yeah, that point very interesting, because a participation from the private sector in this sort of venture is quite crucial to make it possible in terms of the utility of the wood products that we have here. What would be your, I mean, you have been successful in Canada. We have just begun in Thailand. And the participation with the private sector is important to the very successful implementation of this sort of thing. What would you say about the role of the private sector? I mean, where would you suggest to unlock, if I may, if I may say, that kind of block? Because I mean, simply put, is to invite. How do you get private sector, using the Canadian example, into the mix?
You're asking the most important question. First of all, I think one could look at case studies, and it could be a very good research project from your staff to collect information from around the world, why it works, how it works in terms of economics. And of course, different countries have different labor costs, for example, different construction techniques and material costs. But that should be documented and form a framework in which one could establish a business case for a system in Thailand, for example. I think that would be an important start. And secondly, to be able to visit other successful projects all around the world, I think it's important. All the document in the world is good, but seeing is believing, right? And to experience a wood building and looking at the performance of the building, yes, I think that's important. For example, one very important step that can justify this type of large building to be built is the speed of construction. That means that you need to couple the creation of these wood products in a factory-built environment. So lots of things need to be done. You have research that needs to be done. You need to establish an industry that can create this type of product, and then have a building system that fits your conditions in Thailand, for example. That's. But you're a very difficult question to answer.
I also, speaking from our role as educator, university professors, we train and teach next generation of engineers and architects. I think it's also very important to get the engineers and architects exposed to this new idea of using wood in building construction. So we should really, I think we play a critical role for this sort of the public education and training of these engineers, architects. So university.
And lastly, I think you also need to be able to convince government, the Code and Standard Authority, that this is a viable system, safe system, durable system for Thailand, right? And of course, from the industry point of view, Thailand will be one area where they can apply the product. Perhaps even neighboring countries that could take up some of the products made in Thailand. That will be another business case that one should explore. In a tropical country, I think you mentioned before, there are mass timber building built in Taiwan, in Singapore.
Yes.
So it is done. It is being done.
Is there any factor that we should concern, like for building the wood construction in like tropical country like here?
Like any other area, we are concerned with structural safety. We are concerned with fire resistance. We are concerned with product durability. and in particular in a climate, the tropical climate, the durability issue need to be really carefully taken into consideration. And there are ways to deal with that. Techniques that we may not use in North America, for example, in Canada, but they could be used in Thailand.
So that those concerns can be addressed. Yes, you are saying nothing is impossible.
No.
And in this part of the country in Thailand, we have a lot of rubber plantations, oil palm plantation, and coconut, for example. But they are quite. They're big trunks and all of that. But you see as an advantage at all the fact that we have plenty of these types of woods,
Yes. The ballpark numbers that I had back a few years ago, making these engineered wood products, 50% of the cost is in the raw material. Now, if you can come up with utilizing underutilized material such as your stock from oil palm, from rubber wood that has been cut after its commercial value has exceeded in terms of producing the material, you have a very huge advantage commercially, right, dollar sign wise, because if you can come into the picture with a very low cost raw material, that is so important.
And it's interesting that the center that Professor Lee is at is Sustainable Timber Built Environment, and your center, is Wood Building Design and Construction. Are this research center multidisciplinary? Because you were talking about producing engineer and architect. Is it multidisciplinary?
Yes, we are working in the same department, and currently Professor Lam is leading a Sustainable Timber Built Environment cluster. It's a research and education cluster. In total, we have 5 professors. We have different background. We have structural engineers. We have fire engineers. We have building sustainability engineers. So we are working together to work on different aspects related to timber building construction.
Fire engineer.
Yes.
Interesting.
Yes.
And of course, we have colleagues on campus that are from architecture department, from structural engineering, civil engineering department, all really working towards the goal of expanding, if you like, the use of wood as a sustainable building material, green building material, and to create solutions that are good for the environment, good for the citizens around the world, and safe and economical structures.
So by nature, this sort of research must be multidisciplinary, and interesting to have even a fire engineer to be part of it, which is probably one of the most important aspects to make sure that buildings are fireproof.
Yes. Fire resistant.
Fire resistant. Yes, that's correct. Yeah, that's. And do you see? Now you have visited Walailak University. You have met with a researcher at Walailak Universities and all of that. Do you see the extent to which we can make contribution to this area, both in terms of research and would probably be in the future for commercial purposes? But to start with, you think we can? Walailak University be a big part of the research in this area, because it has a great potential?
Yeah, I believe so, especially in dealing with the resource that unique to Southeast Asia. We don't know too much about the oil palm trees and rubber wood. You know much more than we do, but we know a lot about, for example, the manufacturing of wood products, the structural side, the building side. So there's a synergy that can be created between the universities. And I believe very much that exchange of research personnel, exchange of ideas, and joint research will be an item on the agenda that should be encouraged and pursued. So to me, yes, I think coming from your side, there's a lab that the center that you have that can specifically develop to process this type of material, and of course that is important aspect that can be advantageous to the overall scheme of reducing carbon in the atmosphere.
Yeah, because I guess that is something that is on everybody's mind, our role in trying to reduce the carbon dioxide emission. So people in different areas will have to take into consideration their role. And from the engineer, from the architecture point of view, it's also very crucial to think about buildings that could help with that, storing the carbon dioxide. That is a great innovation and a great contribution to the world, reducing the effect of the climate change and all of that. Yeah. I guess the other thing is, of course, we are talking here about training, as Professor Lee was talking about, training the new generations of researchers and practitioners. So perhaps both universities can work on postgraduate studies program producing masters and PhD students.
Yes.
And how big is your postgraduate studies and UBC in this area in particular?
In this area, I would say, I just mentioned we have a research cluster, and pretty much every cluster members is supervising masters and PhD students working on research topics related to mass timber construction, structural fire, sustainability, and relevant areas. I can't remember how many. We do have a bigger group of graduate students working together really to deliver solutions for more use of wood in the construction sector.
It's very encouraging, very encouraging to hear that there are younger generation of researcher and practitioner being interested in this sort of research.
And it's so important, as I said, to get them exposed to the idea of using wood, because we know compared with concrete and steel, wood is a lot of greener material, and they are much better construction material, in my opinion, for the environmental benefits.
And then, is there such a demarcation between using wood to produce buildings and some might think that this would lead to deforestation? Would that be a concern there?
Oh, it was a concern many years ago, but we have sustainable forestry, which means that, for example, in British Columbia, every trees that we take from the forest, there's responsibility from the private sector to replant, and typically they would replant 3 seedlings. So we want to be able to the forest. We want to be able to regenerate. It would regenerate by itself, but by planting, it's going to provide some guarantee that it's going to be very successful in terms of regeneration. So we are not deforestation is no longer an issue in North America, in Europe. The key word is sustainable forest management, and that need to be done. That need to be done with a strong enforcement effort from government and bodies that would oversee this type of action. Right. There's a code, a forestry code, for example, that the company that that involved in forestry has to adhere to. Otherwise, it's against the law, right?
Right. Okay, we have come to the end of the program, and I would like to again thank the two professors from the University of British Columbia, Professor Frank Lam, Senior Chair Professor, and then Professor Minghao Lee, Associate Professor at the Sustainable Timber Built Environment, both of whom are from the University of British Columbia. Thank you very much for joining the Walailak University Global Program. Thank you.
Thank you for hosting us.
Okay.